in this region. So to calculate the thermal problem, I would like to pass the results from DC conduction analysis to thermal analysis. Now I create the new problem and give it name thermal. This would be the steady state heat transfer problem. And again, the length units are microns and the model thickness is 1 micron. Now, in order to pass the data from electric to a thermal problem, both problems should share the same geometry model. So instead of creating new geometry model, I click the browse button and select the geometry model I used in electrical problem. Now here you can see both problems, DC conduction and thermal problems, are based on the same geometry model. But for the thermal problem, for the same materials, I should specify thermal properties. So here I should type in the thermal conductivity of copper. I do not specify the heat source here, because the heat source will be imported from the electric problem. Now, this object has no meaning in the thermal problem, so I do not specify any value and just leave it blank. And this object has no meaning too in thermal problem, so I do not specify any values here. We have not specified yet the cooling, so I should select the surface Here you can see I selected the surface of the copper, open the properties and type in new label. And for this label I specified the convection boundary condition, which has alpha coefficient equal to 5 and the ambient temperature equal to 20 degrees, and the radiation condition with coefficient 0.8 and the temperature the same, 20 degrees. Now you see, as both electric and thermal problem shares the same geometry model, the cooling label I assigned to the external surface also appeared in the electric problem. Well, this cooling label has meaning only in the thermal problem, but has no meaning in the electric problem. Here, and do not specify any data. Now let's run again the analysis. I should resimulate electric problem because new label was added and the geometry model was changed. The same result, and I can run the thermal analysis now. You see zero temperature. Well, not zero exactly, 20 degrees ambient temperature. I forgot to make the link, to put the link between electric and thermal problem. You see there is no link yet. You should follow to the problem properties, follow to the link step, choose the link type, the generated heat, and select the problem. And you should add this link to the data sources. The result calculated in the electric problem will be used as the heat source in the thermal problem.